Uh, as far as the class opener goes, I'll talk you through the notation and what it looks like for doing derivatives of compositions here. So this connects a little bit to what we did yesterday. Want to just give you a feel for what it looks like. The first function, h of x, is some sort of function squared. Now, the first thing to know with chain rule is to recognize that you've got a composition of functions. You've got an inside function f of x. You've got an outside function that squares that. So the inside is f of x. The outside is x squared. Okay. So when you're doing chain rule, I recommend, it doesn't have to be done this way, I recommend identifying inside outside first, but then differentiating outside inside. So what's the derivative of the outside function? What's the derivative of x squared? 2x. But when you differentiate the outside, don't write it as 2x, write it as 2 and then parentheses, because what goes into the derivative of the outside? The inside. So the inside, you're differentiating with respect to the inside, so that stays the same. In addition to that, the Tootsie Roll center has to change after you eat the hard candy shell, so we'll then multiply by f prime of x. Okay? So the 2 is from the derivative of something squared. Squared becomes 2 times something, and the inside stays the same as you're eating the Tootsie Pop. Some of you are already finished. Some of you are like the owl. You remember the old commercial? How many licks does it take to get the center of the Tootsie Pop? And the owl goes 1, 2, 3, and then bites into it? No? Okay. We'll have to YouTube it later. All right. So when we're looking for so we do the derivative of the outside leaving the inside the same. We're eating the candy shell of the Tootsie Pop while we leave the Tootsie Roll center, f of x, the same. And then we change the Tootsie Roll center. That's the f prime of x part. So if we want h prime of 3, it's going to be 2 times f of 3 times f prime of 3, and 2 times f of 3 based on our table. F of 3 is 1, so this is 2 times 1. F prime of 3 is negative 3, so we end up with negative 6 here. Is that okay? Okay. Looking at the second one then, we've got a little more classic composition where both functions are unknown. We just have data in the table. So f of g of x, what's the inside? G. What's the outside? F. So we identify inside outside, then we differentiate outside inside. Does that make sense if I say it that way? Do the derivative outside inside. What's the derivative of f? Just, we don't know what f is, so it's f prime, right? With the inside remaining the same. So we need to leave g of x on the inside. That's the Tootsie Roll center. Now I multiply by g prime of x. If I want j prime of 3, I'm just going to put 3's in. This is going to be f prime of g of 3 times g prime of 3. You've got to do a composition there. I'll kind of leave the work to the reader, but this ends up being negative 5 pi. Can you find it, or do you need more help finding the negative 5 in the pi? Okay. Third one then. Third one involves quotient rule. Not so much on the chain rule here. This is a quotient rule review. F plus g is the lower function. F is the higher function. So when we want k prime, we could even shortcut this a little bit. You okay with me shortcutting just a little? K prime of 3 is going to be low at 3. D high at 3. So low times d high. Less minus high at 3, f of 3, d low. And this is nice because the lower function is just the sum. The derivative of a sum is the, gosh, it's one of those old rules that we forget because we were so complicated. The derivative of a sum is the sum of the derivatives. Good? So this is just f prime of 3 plus g prime of 3. Now that we have all these complicated rules, those older, simpler ideas get a little cloudy, don't they? Just if we're being honest about it. And then this is all divided by the lower function squared. F of 3 plus g of 3 squared. And I'd like you to plug through that algebra. Excuse me, it's not algebra anymore. I'd like you to plug through that arithmetic. I think I did it pretty carefully. I got negative 19 over 81. So if you plug through that at some point down the road. The purpose of today then is to take chain rule and kind of combine it with some of the other rules we've already played with. So I've got an example where chain rule ties in with product rule. I've got a problem where chain rule ties in with quotient rule, and then I've got a problem where you have to find the slope of a tangent line a little bit later on. So let's take a look at this one. We have a function that is a product of two functions, and our job is to find the derivative of the product. But things to notice: it's not a typical product rule because the derivatives are funky. Each of those portions of the product are going to involve chain rule. So for simplicity, what I might do is I might separate off these two parts of the product as those two, the 3x plus 1 to the fourth and the 5x minus 3 squared. And then the 2, I love coefficients, guys, and I hope you start to love coefficients too, because coefficients, as long as you remember to do so, you can just tag them on the end of the derivative. Because the derivative of twice a function is twice the derivative. So that's something that's nice that we'll hold on to a little bit later. With product rule, we defined each function. Let's say this one is h of x. Let's use colors that match though, huh? And we'll call this one h of x. And we'll call this one g of x. Okay. Product rule involves derivatives of both of those things, so let's take them one at a time. And hopefully this can add some clarity to the chain rule stuff we did yesterday. Because both of these h and these g's, in this example, are pretty straightforward chain rule problems. So h prime of x, anybody daring enough to take a shot at it? Derivative of h. H is that 3x plus 1 to the fourth. Identify the inside. What's the inside? 3x plus 1. What's the outside? X to the fourth, right? What's the derivative of x to the fourth? 4x cubed. But when I'm doing chain rule, I don't write the x in there. You with me on this process? It's 4x cubed, but I don't write x in there for the outside function. What do I write in there? 3x plus 1. That's the inside function. It stays the same. Am I done? No, all we did was eat the candy and we skipped the Tootsie Roll Center. Don't skip the Tootsie Roll Center. It's really good. So what do I have to multiply by? 3. Good? G of x. Let's go G prime. Same idea. G prime is what? 2 quantity to the first, right? Do I need to write to the first? Probably not. What goes on the inside? The unchanged Tootsie Roll Center, right? Tootsie Roll Center was 5x minus 3. And I multiply by the derivative of the Tootsie Roll Center. That's 5. That's a multiply right there, guys. Sorry, it kind of looks like a subtract. Good? Now, the good news is you don't have to do a whole lot of simplifying. You're just going to write out product rule at this point because I've got a function times a function. So I'm going to put the f prime, I'm going to put the 2 in front, and then I'm going to do the derivative. Hopefully there's enough space in there. Okay? What do I do next? Product rule. What should I write first? 3x plus 1 to the fourth times, you don't need to tell me the symbols, just tell me the name, g prime, which would be, I'm going to simplify that just a touch, guys. I'm going to write that as 10 times 5x minus 3. Just going to simplify it a touch. Plus, what goes next? We could do 5x minus 3 squared. I like to do the f part first. So I'm going to go blue, red, just based on what I see. So this is going to be 12 quantity 3x plus 1 cubed times 5x minus 3 squared. Okay? Questions at this point? That's the end of that one. Do you want to simplify? I mean, if you wanted to, you could. I mean, you could write this. You could write this first part as 20 times 3x plus 1 to the fourth times 5x minus 3. I wouldn't spend time trying to find out what 3x plus 1 to the fourth is. You could write this as plus, so I'm distributing the 2. 24, 3x plus 1 cubed, 5x minus 3 squared. I mean, could you factor out what's common? Sure, you got a 5x minus 3 in both, you got a 3x plus 1 in both, you got a factor of 4 in both. If you want to, you can. It's not worth our time at this point. Question? Question is, where did the 10 come from? The 10 came from the coefficient that was already there, or I'm sorry, the coefficient that came from the exponent for the derivative times the derivative of the inside. Okay? Other questions so far before we move on? Okay, are you ready for it to get a little bit disgusting? What we're doing with this one is this is a composition of 4 functions. Okay? You okay with this? Let's identify it. Now, we're going to identify functions from the inside out, and we're going to differentiate from the outside in. Does that make sense if I put it that way still? So what is the... I'm gonna change up the notation a little. I'm just going to call this y because I want to use f for one of the functions. Okay? So, the innermost function. The innermost function is which one? Even inside the e is 7x to the fourth. The key here is we haven't spent a ton of time on e's yet, but if there's something other than a number or something other than just a plain old x inside that exponent, it's a function inside of a function. So the innermost function we will say is, let's start with f. Let's go inside out. F of x is 7x to the fourth. Has a pretty basic derivative, right? You know the derivative of 7x to the fourth? Good? Yeah? Good. So let's go next one. Working inside out. What's the next function? What does 7x to the fourth go into? E to the x. Let's go h of x. What does e to the x go into? Sine x. And there is one more. What is it? Let's call this j of x. X to the fourth. Okay? Just to clarify, sine to the fourth is really sine to the fourth. So that's the outermost function is the fourth power. Okay? Question? Yes, that's the innermost to the outermost. Now, when I differentiate, I'm going to differentiate outermost to innermost. And each step along the way, when I differentiate the outer function, I'm going to leave that whole inside the same. And if it's inside something, it stays the same for that first step. This is going to get a little bit complicated. So let's do this. Let's do derivatives over here. Let's do derivatives. Okay? What's the derivative of x to the fourth? 4x cubed. And I'm going to leave a space there. Okay? What's the derivative of sine? Cos. What's the derivative of e to the? E to the. What's the derivative of 7x to the fourth? 28x cubed, right? Oops, I'm not consistent, guys. 28x cubed. Leave space there. All right? Now I'm going to work derivatives outside in. So the first thing I'm going to do is I'm going to work bottom up now. I'm going to work with j first. I'm going to write the derivative of j. The derivative of j is 4 times something to the third power. What do I put in? What do I put in? What goes in here? Cosine goes in. I don't want to change the inside. I want to change the outside. I don't want to put cosine in there. I need to when I do the derivative of the outside, the Tootsie Roll center needs to stay the same. So this is going to be sine e to the 7x to the fourth. That's the first step. Good so far? Now I need to start differentiating the inside. Oh boy. What's next? What's the next outermost function? I took care of J. Done. Yay. Next is the sine, so I'm going to write cos, right? Cos what? E to the 7x to the 4th, right? What else goes in this stage of the work? What else do I need to multiply by? The derivative of e to the 7x to the 4th. So that's the next step in the chain, right? Good so far? Next step is going to be e to the 7x to the 4th times 28x cubed. Okay. The red one comes from here. Because e is its own derivative, right? I did cos, so now I need to differentiate the next step. I need to differentiate the e to the 7x to the 4th. That's a chain rule problem too. The derivative of e to the is e to the. And then since that last function is the very innermost function, I multiply by its derivative last. That is our answer. Could you make it 28 times 4 in the front and work down? Yeah, absolutely. Okay. It's called chain rule because it's a repeated iterative process over and over again until that last function on the inside has been differentiated. Question? Good question. Does the e to the make the coefficient move down? The quick answer is no. If I have e to the something, its derivative is e to the something. It does not follow power rule. It does not follow power rule. It's got its own rule. Okay? So, long story short, let's just say I had, just deleted the page. Let's say I had e to the x squared. This is a composition. The inner function is x squared. The outer function is e to the x. The derivative of the inside is 2x. The derivative of the outer is e to the x. So if I'm using chain rule to differentiate e to the x squared, my derivative with respect to x is going to equal e to the inside left the same, e to the Tootsie Roll center, times the derivative of the inside, 2x. So the derivative would be 2x e to the x squared. Does that help a little bit? Doesn't follow power rule because you don't reduce the exponent. Questions on that? Let me go back to the other one. Should we apply it? Just a little. I think this is the last one. This is the last one I have for right now, and then I'll give you a bunch of work time. All right? So, it looks a little different. Write the equation for the tangent to the function at the given point. I left a word out. What is a tangent? Tangent's a line, so I put that word in here. We don't need it, but you can impose it on that sentence because it's not always going to say tangent line. What do we need in order to write the equation for a line? Point and a slope. We need a point, and we need a slope. Which one's easier? Point or slope? I think the point's easier because you've already got the function, right? What do? The point is 3 comma something. How do we find the something? Plug it into the original. We want f of 3 in order to get the y coordinate. F of 3 is 3 plus 1 is 4. 3 minus 1 is 2. We're going to cube that. 4 over 2 is 2. 2 cubed is 8. So we have an ordered pair. 3, 8. Calculus notation. What is the slope? Using notation. Function calculus notations. The slope of this is derivative at 3. How do we write that? F prime of 3. This is what we want. We want f prime of 3. Do we have f prime of x? We sure don't. Okay. We need f prime of x. We have an so we identify functions inside out. We differentiate outside in. What's the inside function? X plus 1 over x minus 1. You know how to do the derivative of that? Quotient rule. So the derivative with respect to x of the inside is equal to low d high less high d low all over low squared. Good? What's the outside function? X to the third. What's the derivative of that? Three x squared, right? Good so far? F prime of x is equal to 3 inside squared. Inside is x plus 1 over x minus 1 times, I'll slow down, sorry, I'm going fast, guys, I'll slow down. Then I'm going to multiply by all this stuff. Little bit of thought for you. Think about problem-solving strategies right now. Is it worth our time to do a simplifying on the derivative? Is it worth our time to simplify? No. We're not going to do anything with it except plug in 3, right? So really, I want f prime of 3 now. That's going to be 3 quantity, 4 over 2 squared. Just putting in 3 for both of those x's. 3 plus 1 is 4. 3 minus 1 is 2. Times 3 minus 1 is 2 minus 2 plus 3 plus 1 is 4. All over 3 minus 1 is 2. 2 squared. I'm going to find the value of the derivative. Let's see. 4 halves is 2, so this is 12 times 2 minus 4 is negative 2. Negative 2 over 4 is negative 1 half, right? Negative 6, okay? Will you double check my arithmetic there, please? Is that okay? Does that look right? I did that kind of fast. I did it before and got a different answer. Will somebody check and make sure you get the same thing? Looks good. I had to check my work on the first time I did it. I got a different answer. Okay. So we have a point. The point is 3 comma 8. The slope is negative 6. How do we write the equation for a tangent right now? Is that okay? Okay. We are going to do a quiz tomorrow. Leaning towards partner quiz. Partner quiz? Partner quiz tomorrow on chain rule? Yeah, you can pick your partners this time. Is that what you got?